So now we're getting into the little more challenging stuff, and these are pretty awesome because being able to take a word problem or like a real world scenario and turn it into the abstract where you just have like variables representing it, it makes it universal to where you can use it for all sorts of different things. So these are challenging, and even after I explain them, they should be challenging. So make sure you're giving yourself ample time to pause this when you need to, and you're figuring out how all of these work. So, skiing. Hugo is buying a pair of water skis that are on sale for 2/3 off the original price. 2/3 of the original price. After he uses a $25 gift certificate, the total cost before taxes is $115. And the reason they say that is taxes would just make things a little bit more complicated. So it'd be better to figure this out without taxes before you did one with taxes. What was the original price of the skis? Okay, well let's go ahead and tag what we're kind of curious to figure out over here. Well, X, that's what we don't know. And since they're asking us what was the original price, let's write original price. And if I were to see this as like being an event, well, you go up to the counter, you hand these skis over to somebody. Well, like you have to take the discount off of it. Well, it's on sale for 2/3 of the original price. So here's the original price, and this is 2/3 of this. Now I see a gift card, and I'm like, well, that's usually a good thing, right? Like it's like a benefit. So I'm like, well, I'd probably add that. But really, you're taking it off of the sale price before you end up being charged something. So I'm going to subtract 25 instead. So let's be clear about that again. X represents the original price. I'm taking 2/3 of that. Then they're like, okay, well, hey, you owe me this. But because I have a gift card, I'm going to say, hey, wait, first I'm going to subtract 25 from both sides. I'm sorry, from that price. Before, it'll end up being 115. So after I do all those things, that's when I then pay $115. And this is a word problem, so whatever we do, we can recheck and see if it makes sense. Well, let's add 25 to both sides. And if we figure out that we made a mistake, and our work ends up being a dead end, that's okay, we just have to try things over again. Word problems are a repeated process, and a iterative process. And what I mean by iterative is it's like you take a stab at it, maybe you get 50% of the way there. Then you come at it again, maybe you get closer and closer and closer. But you're always kind of re-challenging your thoughts to get to the final answer, and they get better over time. 115 and 25 combine to give me 140. Now, I'm going to sidestep for a moment. If this was an old problem, like where you just had x over 4 equals something, you could just multiply by 4. But we have a fraction out front with a numerator and a denominator that both have values. So it's going to be best to multiply this one by its reciprocal. So here's 3 over 2. Now I know that these are going to cancel out on the left side, but I don't want to cancel that out because it makes me think I'm canceling it out with that as well. Whereas really I'm distributing this. So there's 3 halves of 2/3, so the only thing I have on the left is x. And I'm going to rewrite 140, but not just 140, it's got to be times 3 over 2. Now I like taking halves of things, so I see 140 as being in the numerator, and 2 in the denominator, and I still have to write 70, and I like to sneak it above the 140 so that it's clear. And then I have x still is on the left side, and I'm scanning through my complicated looking fraction stuff, and 70 times 3 is 210. And there's nothing in my denominator, so I'm going to throw that $sign out front. Now, does this seem reasonable? Well, it was 115 after we paid for everything, and if you had something for 2/3 of the original price, but you use a gift card, that seems pretty reasonable. But let's check it in our equation first, even though I think it's better to check it in the real-world problem. I want to check it in the equation just so we can get our work on paper. So 2/3 of 210 minus 25 is 115. Well, 210 over 3 becomes 70. Times 2 is 140. And yeah, you do get 115 on the left and 115 on the right. And you're good to go there. So as I look at this, well, let's think about going up to the counter with a $210 pair of skis. Okay, well, in red, I'll write this. Well, 210. Well, the discount price was going to end up being 2/3. So I took 2/3 of that, and once I did that, I only had 140. So they're like, hey, we're going to charge you 140. I'm like, no, I got this $25 gift card, dude. You better back up. And they're like, okay, glad Grandma got that for you. Here's a $115 receipt. Can you dig it? Write an equation for the following problem, then solve the equation. Okay, so we got to turn this into an equation. 16 is, well, there's my is. There's my 16. And it is equal to 7. I had to replace this because of some printing issues. 7 increased by, well, then I'm taking 7 and 7 is getting larger. So it's being increased by the product of 3 and a number. I'll do y this time. All right. Make sure you can come up with that, because from here on out, solve this on your own and check it. Even though it doesn't say check it, just check it. I'll put the answer up in 4 seconds. Take a moment, figure this out. You're pretty comfortable with, being able to just jump from here to there, I think, by now. If not, you would have shown it as another step, and my check proves this to be accurate. Now, these get pretty challenging. They're also really fun. So, solve consecutive integer problems. Well, let's talk about what it means to be consecutive. Consecutive numbers, anything that's consecutive is usually back to back. So like 1, 2, 3, 4 would be consecutive. I could also say, 5, 10, 15, those are kind of back to back. But if I wanted to say things that were more specific, I would, give different limitations. So I'm going to use the word consecutive, but then I'm also going to limit it to being even. So if I said these had to be back-to-back even numbers, and I began with 10, the next would be 12, 14, and so on. So because it's consecutive and even and integers, negatives can be involved. So they usually show how things behave close to 0. So if I was walking towards 0, I would say -4, -2. I'd step at 0, and then I'd say 2, 4, 6, 8, and so on. Whoops, that was supposed to be an erase. As far as consecutive odd integers go, we're not going to see 0 because it wouldn't stop at 0. I would say -3, -1, 1, 3. So write equations for the problems below. The numbering might be off, so you can ignore this if that bothers you. Write equations for the problems below, solve the equation, and answer the questions. Find 3 consecutive integers whose sum is 74. It does not say even. It does not say odd. So these are just numbers that are back to back to back. Now you can do these through trial and error. Like, let's pretend that it was 20. We think the answer is going to be 20 because I know that I can do 20 times 3 and get 60, which is kind of close, so let's pretend it's 20. So over here, way off to the side, well, let's say 20. Well, if 20 was our starting number, it would be x, and then our next number would be 21, and then our next number after that would be 22. Well, what would happen if I added all these? Well, I'd get 20 and 21 and 22, and I'd get 63. Well, that would be a mistake, right? So I'd be like, well, I know I have to either increase or decrease that number because it didn't match 74. So instead of 20, why don't I begin at 22? Erase this right column of numbers. And let's go through this again just so we understand the concept. Well, if I begin at 22, my next one is 23. My next one is 24. So I'm chunking this, and I'm kind of breaking it apart to help see this. And since this 4 and 3 becomes 7 and 2 is 9, we don't get quite high enough to where we pass that up. Well, it looks like we're getting closer and closer to the right numbers. So let's go back and erase this again. And do you think you go crazy higher or just a little higher? Well, let's go with 24, 25, 26. Okay, I'm adding 4 and 6 first. And I'm getting 10, and 5 is 15. And then I'm getting 75. Well, we have an issue here, and actually that issue is this. Nothing's going to work for this one, so let's change our answer to 75. I apologize if that threw you off. That's back to the whole printing issue. When these add up, I do get 75, and I did have to change the problem because that's the only way to work out. We would not be able to, because if I counted back down one, I'd end up at 72. Okay, let's compare x equals 24 versus 25. Well, let's think about how I would write this with x. Well, if x is 24, then what would I have to do to this number on the left to get it equal to 25? Well, I'd add 1. Well, that makes sense because as I go, stepwise, and I'm just counting up, if this was x, the next value would be just 1 larger than x. And this next value would be 2 more from where I started. Because this would be x plus 1, and this one would be x plus 1 twice. So as I go step to step, I can look at it a couple different ways to see how I could figure out these consecutive integers. Now that I've spent a good amount of time on this, let's look at what this means for how I would do it using only algebra. So if I had 3 consecutive integers, the first one would be x. I'm going to make my plus sign in black, and I will use parentheses to make my next value stand out. Because that green x is the first term, this blue x plus 1 would be my second term, and then in a different color still, my third consecutive integer, my third term, would be x plus 2. Now I don't need these parentheses, so I'm going to write it without them. I only wanted to show those parentheses to help them stand apart. Now we have a combining problem. I see x 1, 2, 3 times, which means I have 3x. I scan moving on to regular numbers. 1 and 2 gives me 3, so I'll have 3x plus 3. And we knew that the 3 consecutive integers, when added up, should be 75, after we realized the problem was flawed. And I realized I should move this over, shouldn't I? Here's 3x plus 3 equals 75. Now I can just solve this. And then when I divide 3x by 3, I'll get x is equal to 24. But here's where it gets kind of interesting. So there's 24. Sometimes you're like, whoa, what does that mean? Does that mean my numbers are 23, 24, 25? No, the way we set the problem up was where x was the very first choice. And since x was the very first choice, that means that the 3 integers back to back would be 24, 25, 26. And we've already talked about this enough to where we don't have to check it, because that agrees with what we did. But you would just take those 3 numbers and add them, and you would know you were good. These are complicated problems, but man, when you figure them out, they're fun. Find 3 consecutive even integers whose sum is 42. So over to the side, let's write, well, 2, 4, 6. Trial and error worked great here, but in dealing with these negative numbers, this might not even seem to make sense until we get to the answer. So we see how, well, okay, if I want to make these work, I might have to use some algebra. So if I know my first number has to be x, well, my second number, how far away is 4 from 2? So in the last one, we just did x plus 1. But because it's even, it's 2 steps up. So my numbers are x, x plus 2, and x plus 4. And that's because when I go from one number to the next, but I'm, by a rule, having to go 2 up because they're even, that's what's happening. It's changing my problem. So again, my first even integer is going to be x. And I'll do the color thing again. I'll make that green. My second even integer is going to be x plus 2, which I'll show in parentheses like the last one to help it stand out. And my last even integer would be x plus 4. All of this should be equal to negative 42. And I know I'm repeating myself a lot, but it's kind of to help hammer home the concept. Okay, pretend x is 10. If x is 10, then 10 plus 2 is 12. If x is 10, 10 plus 4 is 14. And I can see how these are consecutive, even integers, and I skip over 11, and I skip over 13. So again, I'm showing it multiple ways and talking about it a lot, just to really make it confident. So here's my parentheses not mattering anymore, x plus 2. I'm budgeting space, and I know I can bring this tighter to my equal sign. And I have 3x on the left, 6 on the right, and negative 42 on the other side of the equation. Subtract 6 from both sides. 3x will be negative 48. Notice how I sped up? Well, that's because I think the algebra part you got on your own. So this would be negative 16. On purpose, I'm going to do this the wrong way. So that means your first even integer is negative 16. And let's say you're like, well, okay, that means that the next one's got to be negative 18, negative 20. If I added all of these up, I think I would get negative 54, if I'm doing that correctly in my head, which is not correct. So as you do these, don't forget, as you move from negative 16 to the right, you're actually getting closer to 0, so negative 14 and negative 12 would be those consecutive integers. When I combine these, I see negative 30 minus 12 is negative 42. So when I add all three of those numbers up, they check out, and those give me the 3 consecutive even integers. Make this one an OYO problem, and see how you do. These are 3 consecutive integers. You might be able to do it with trial and error, but make sure you're doing it with algebra. I'm going to show the work in 5 seconds. There's the answer to that. I won't talk about it. Keep in mind this section is probably going to be pretty comfortable with just the algebra problems, but definitely challenging when you get to the word problems.